Whether you're starting your day with that first perfect cup of coffee or catching up on the drive to work, you've landed in the right place for fresh thinking about automotive's AI revolution. I'm Steve.
And I'm Claire. We're part of the Agentic team, and this is Auto Intelligence, your deep dive into the intersection of automotive, artificial intelligence, and mobility innovation.
New episodes drop every Tuesday, Thursday, and Saturday. And honestly, the pace of change we're covering keeps us as energized as our morning caffeine. Before we jump in, we want to thank our growing audience. Your engagement and feedback drive everything we do here.
Today, we're exploring something that's fundamentally rewriting the story of automotive manufacturing. Picture this. It's 3:47 a.m. in Detroit, and Maria Santos, BMW's head of manufacturing intelligence, gets pinged about another production line halt. The third this week.
But here's what makes this moment different and why we're diving deep today. Maria doesn't just see another crisis, she's witnessing what our source material calls the last gasps of an era. Because across the industrial landscape, two specific types of AI are quietly orchestrating a revolution.
We're talking about generative AI and agentic AI. And these aren't just buzzwords. They're twin engines that are transforming not just how cars are built, but who builds them and what it means to be human in an increasingly intelligent manufacturing world.
The numbers tell an incredible story. The global automotive AI market exploded from $10.88 billion in 2024 to a projected $17.56 billion in 2025. That's a 61.5% compound annual growth rate.
And by 2025, 78% of automotive manufacturers had implemented some form of AI, up from just 62% 2 years earlier. Steve, this isn't gradual adoption.
It's a stampede toward intelligence. And what's fascinating is how these two branches of AI, generative and agentic, are creating completely different but complementary transformation stories.
Let's start with the generative side, because this is where we're seeing some truly mind-bending innovations. At General Motors, there's this component, an aluminum bracket, that perfectly captures what generative AI can do.
Quinn, an engineer at GM, described holding this bracket and saying, 6 months ago, no human engineer could have designed this. The AI generated 2,000 iterations in the time it would have taken human designers to sketch one.
And this wasn't just about speed. This single bracket consolidated 8 separate components into one 3D printed part that was both lighter and stronger than anything human designers had ever conceived.
But here's what caught my attention about Quinn's reaction. He said, "Sometimes I wonder if we're designing ourselves out of a job. That tension between awe and uncertainty, that's at the heart of the generative AI story in automotive."
Mercedes-Benz Chief Design Officer Gorden Wagener captured this perfectly. He predicted that in 10 years, maybe most of the design will be done by AI, and it will make designers obsolete. But then he immediately added something crucial.
You get 99% of crap with AI and sheer quantity, but you get 1% good stuff, and we keep learning. So the real skill becomes human judgment, recognizing, refining, and realizing the best of what AI can generate.
Which brings us to the other half of our story, agentic AI. While generative AI is reimagining what's possible in design, agentic AI is creating autonomous systems that can perceive their environment, make decisions, and take actions without human intervention.
The example that really struck me was at Volvo's safety research facility in Gothenburg. They're using something called Gaussian splatting to reconstruct real-world traffic incidents in photorealistic detail.
Alwin, Bakkenes, Volvo's head of global software engineering, explained how they can select one of the rare corner cases and explode it into thousands of new variations of the scenario to train and validate our models against.
Think about the implications here. Traditional safety testing required years of real-world data collection. With agentic AI, Volvo can compress that timeline from months to days, exploring dangerous scenarios in virtual environments that would be impossible to recreate safely in the physical world.
And this connects to something Jensen Huang said that really frames both of these AI revolutions. He described AI as the automation of automation, where software writes software.
Huang's vision extends to what he calls two factories: the factory for what companies build and the factory for the mathematics, the factory for the AI. It sounds like science fiction, but it's already happening.
Let's talk about BMW because they're implementing both generative and agentic AI in fascinating ways. Their Regensburg facility has an AI-powered predictive maintenance system that quietly avoids an average of 500 minutes of assembly disruption per year.
But the real breakthrough is their Car2X technology. Every car on the production line becomes an active participant in manufacturing, communicating in real time with the production system, self-analyzing, and sharing critical information with human workers.
BMW describes it as the vehicle itself becomes a communicative and intelligent participant in production. We're not talking about passive objects moving through an assembly line anymore.
They're collaborators in their own creation. It's a fundamental shift in the relationship between product and process.
Now, we'd be remiss if we didn't address the human element in all this transformation, because while the technology stories are fascinating, the workforce stories are equally compelling and complex.
A 2023 Boston Consulting Group study revealed this stark divide. 77% of workers expressed concerns about job loss due to AI, but only 14% of frontline workers had received AI upskilling compared to 44% of leaders.
But in the most successful implementations, we're seeing a different narrative emerge. At BMW, more than 1,200 employees have been trained as citizen data scientists, empowered to build their own AI solutions using no-code platforms.
These workers aren't being replaced by AI. They're being elevated by it, transformed from manual laborers into problem solvers and innovators. It's reminiscent of what Jung Min-ho, a supply chain analyst at Hyundai, told us about his experience.
Jung had been struggling with increasingly complex global logistics networks, drowning in data and reactive firefighting. But when Hyundai implemented agentic AI systems that could predict semiconductor shortages 3 weeks in advance, his role was completely transformed.
He said, "The AI doesn't replace what I do. It makes me better at what I do. I'm no longer just reacting to problems, I'm preventing them." That's the partnership model that seems to be emerging from the most successful implementations.
You're listening to Auto Intelligence, brought to you by Agentic, the platform transforming automotive retail with intelligent, human-centered AI. What sets Agentic apart is our understanding that true agentic AI isn't just about automation. It's about strategic thinking, collaborative planning, and operational integration. Because in an industry where both generative and agentic AI are reshaping everything from design to manufacturing to retail, you need partners who understand the nuances of automotive transformation.
Now back to our exploration of these twin AI engines. Let's dig into some specific examples of how generative and agentic AI are working together to solve real-world challenges.
One area where this collaboration is particularly evident is in supply chain management. The semiconductor shortage that cost the industry $240 billion was a massive wake-up call about the vulnerability of traditional approaches.
Companies like General Motors and BMW are now implementing AI systems that can predict disruptions weeks or even months in advance. These systems analyze everything from weather patterns and geopolitical events to supplier financial health and transportation bottlenecks.
Penske provides a great example of this transformation. They consolidated disparate data sources into a single AI-powered view of their operations. The results were dramatic. Predictive analytics helped them anticipate issues before they occurred, optimize routes, reduce operational costs, and improve delivery times.
They moved from reactive problem solving to proactive optimization. And this is where you see the interplay between generative and agentic AI. Generative AI helps create optimal routing scenarios, while agentic AI systems can autonomously implement those optimizations in real time.
Speaking of real-time implementation, let's talk about what's happening on factory floors. Tesla's Optimus humanoid robots are no longer science fiction. They're entering production environments. Meanwhile, Mercedes-Benz is testing Aptronic Apollo robots in their Berlin facility.
The vision is audacious. Factories where autonomous robots, guided by AI systems, can adapt to changing conditions, learn from experience, and collaborate with human workers to achieve unprecedented levels of efficiency and flexibility.
But here's what I find most interesting about this transformation. It's not just about the technology itself. It's about the reconceptualization of what manufacturing can be. Instead of linear assembly lines, we're moving toward dynamic ecosystems.
Exactly. AI agents, robots, and humans collaborating in real time to optimize not just individual processes, but entire production systems. It's a fundamental shift from predetermined workflows to adaptive, intelligent manufacturing.
This transformation is also creating entirely new kinds of jobs and career paths. At Audi, which has implemented more than 100 AI projects across its global production network, workers are becoming AI collaborators, data analysts, and system optimizers.
The factory floor is becoming a hybrid environment where human expertise and machine intelligence combine to achieve results that neither could accomplish alone. It's not just about learning new technologies, it's about developing new ways of thinking about work itself.
And this brings us to a crucial point about competitive dynamics. Traditional automakers are finding themselves competing not just with each other, but with technology companies that bring different capabilities to AI implementation.
Tesla's vertical integration and software-first approach has given them significant advantages in AI development and deployment. Companies like Waymo and Cruise are pushing autonomous driving boundaries, forcing traditional manufacturers to accelerate their own AI efforts.
McKinsey projects that automotive generative AI could create $300 billion in annual value by 2035. But that value will flow primarily to companies that can successfully implement AI at scale.
The stakes are clear. Companies that fail to transform will find themselves increasingly disadvantaged in a market where AI capabilities are becoming essential for competitiveness.
Let's talk about the environmental dimension of this transformation, because it's not just about efficiency and competition. AI is proving to be a critical tool in addressing environmental challenges.
BMW's SOAR-DI dataset incorporates information about components' carbon dioxide footprint, age, and energy consumption. This enables simulations that optimize energy and carbon dioxide savings for both factory operations and vehicle components.
The environmental benefits extend beyond manufacturing. AI-powered systems are enabling more efficient vehicle designs, optimized energy consumption, and reduced waste throughout the production process.
As the industry transitions to electric vehicles and sustainable manufacturing practices, AI is becoming an essential tool for achieving environmental goals while maintaining economic competitiveness.
But we also need to address the ethical dimensions of this transformation. While AI is creating new opportunities and capabilities, it's also displacing traditional jobs and potentially exacerbating economic inequality.
The most successful implementations are those that recognize these challenges and work to address them proactively. Companies that invest in worker training, involve employees in AI system design, and share the benefits of AI-driven productivity gains are more likely to achieve sustainable success.
This connects to something we've been exploring throughout this conversation, the principle that the most successful AI implementations preserve and elevate the human element rather than eliminating it.
The future factory isn't one where humans are replaced by machines, but one where humans and machines work together to achieve unprecedented levels of performance. This collaboration takes many forms.
Engineers work with AI systems to explore design possibilities that neither could achieve alone. Factory workers partner with AI-powered robots to perform complex tasks with greater precision and efficiency. Supply chain managers use AI insights to make strategic decisions that balance multiple objectives.
The transformation is creating new kinds of work that require uniquely human capabilities: creativity, empathy, judgment, and the ability to navigate complex social and ethical considerations. These capabilities are becoming more valuable, not less.
And this brings us to some key principles that are emerging from the most successful implementations. First, the transformation is fundamentally about people, not technology.
Companies that focus on changing processes and developing human capabilities are more likely to achieve lasting success than those that focus solely on implementing new technologies.
Second, the transformation requires a long-term commitment to learning and adaptation. AI systems aren't static tools that can be implemented once and forgotten. They're dynamic capabilities that require continuous refinement.
Third, the transformation is creating new forms of value that extend beyond traditional metrics of productivity and efficiency. AI is enabling new capabilities in design, quality, flexibility, and responsiveness that are difficult to quantify but essential for competitive success.
Let's talk about some of the failure patterns we're seeing, because not every AI implementation is succeeding. Forbes reports that 85% of AI projects fail, often because companies focus on the technology rather than the fundamental changes required to make it work.
The most common failure pattern is predictable. Organizations pilot AI solutions without building the underlying architecture for data quality, observability, and governance. They achieve impressive results in controlled environments, only to see those results evaporate at scale.
But the successful implementations share a common characteristic. They recognize that AI transformation is fundamentally about people, not technology. At BMW, AI-powered quality control systems succeeded because workers were involved in training and refining the systems.
Employees used augmented reality to teach AI systems how to recognize defects, creating a feedback loop that improved both human and machine performance. It's that collaborative approach that seems to be the key differentiator.
Looking ahead, we're still in the early stages of this AI journey. The next phase will bring even more profound changes. Fully autonomous factories, AI-designed vehicles, and supply chains that can adapt to changing conditions in real time.
Jensen Huang's prediction of 2 factories, one for physical production and one for AI development, is becoming reality faster than many expected. The question isn't whether the transformation will continue, but how quickly and effectively the industry can adapt.
What strikes me most about this entire transformation is that it's fundamentally a story of human adaptability and organizational learning. The companies that succeed will be those that embrace both the technological possibilities and the human imperatives of this new era.
The engine of tomorrow is already running, powered by the collaboration between human ingenuity and artificial intelligence. For those willing to embrace change, the future holds unprecedented opportunities.
And for our listeners who are navigating this transformation in their own organizations, the key insight seems to be that the most powerful technologies are those that amplify human capabilities rather than replacing them.
As we wrap up today's deep dive into generative and agentic AI in automotive manufacturing, what really strikes me is how these aren't just technological shifts. They're fundamental reimaginings of what human-machine collaboration can achieve.
From Maria Santos' early morning wake-up call about production disruptions to BMW's cars that communicate during their own assembly, from GM's AI-generated components to Volvo's safety simulations, we're witnessing the birth of truly intelligent manufacturing.
The transformation is far from over. In fact, as our source material notes, it's just beginning. The automotive industry's AI revolution is a reminder that in an age of artificial intelligence, human agency and creativity become more valuable, not less.
This has been Auto Intelligence, exploring where automotive meets artificial intelligence. Thanks for joining us on this journey through the twin engines of generative and agentic AI that are reshaping our industry.
This episode was produced by the team at Agentic. Learn more at autoagentic.ai. We'd also like to thank our producer, Barry Hillier, co-founder and CEO of Agentic AI, whose vision for human-centered AI in automotive continues to inspire our work.
If you'd like to reach out with suggestions for future topics or share your thoughts on today's discussion, email us at barry@autoagentic.ai. Barry is always looking for exciting new companies, people, and innovations shaping the future of mobility.
Until next time, keep innovating. And remember, in the race toward intelligent manufacturing, the best partnerships are between human wisdom and artificial intelligence.